Hi everyone, this is AGS Knowledge and Learning channel. So in this video I will explain classifications of system, problems with solutions which can be asked in part A as well as part B questions. Here I have given as MCQs with respective answers which belong to the subject signals and systems. So check whether the given system y of n is equal to x of n plus 2 is dynamic or not. I have given 4 options, but the answer is dynamic system. Y of n equal to x of n plus 2 is a dynamic system. Let me tell you how. So the given system is y of n equal to x of n plus 2. You take for different values of n. You take some negative values, you take some positive value, you can take 0 as well as. Okay. So you substitute in the place of n. So what will be the expression? Y of minus 2 is equal to x of minus 2 plus 2. So minus 2 plus 2 you will get x of 0. So you substitute the other values of n. Minus 1 plus 2 you will get x of 1. 0 plus 2 you will get 2 x of 2. If you substitute 1 plus 2 you will get x of 3. 2 if you substitute 2 plus 2 you will get x of 4. So on this analyzation we can confirm that for different values of n we are substituting negative values, 0 as well as positive values. The output depends on the future values. For example, if the input is 2 means it is 4. Okay, future values. So future values of the input, therefore the given system is a dynamic system. So dynamic system means memory system. Check whether the given system y of t equal to x of t by 2 is causal or non-causal. The answer is non-causal system. Let me explain it how. So y of t equal to x of t by 2. So for substitute for different values of t, negative values, positive values and 0. So if we substitute for example 2, if you substitute 2 by 2, 1. 1 if you substitute 1 by 2, that is 0.5. 0 means 0 by 2, 0. So for different values of n, the output depends on future values of input. Therefore, the system is a non-causal system. So the answer is this. Check whether the given system y of t is equal to x of 2t is static or dynamic. The answer is dynamic. Let me explain how. So y of t equal to x of 2t. Substitute for different values of t. For example, if you substitute 2, you will get x of 4. That is, the output depends on future values of input. The given system is a dynamic system. Check whether the given system is static or not. You have been given a differential equation. So the answer is dynamic. So how? Y of t equal to d square x of t by dt square plus 2 x of t is the expression given. If the system is described by a differential equation, the system is a dynamic system. It has memory. So it is a dynamic system. Check whether the given system is static or dynamic. Y of n is equal to x of n minus 2 plus x of n. This expression we can call it as difference equation, or you can substitute the values also. Okay, you can substitute the values also for different values of n also you can check. This is otherwise called as a difference equation. Since differential equation is a dynamic system, difference equation which correspond to a dt system is also a dynamic system. Difference equation is also a dynamic system. Check whether the given system is linear or non-linear. Y of t is equal to e power x of t. Exponential of x of t they have given. So the answer is non-linear. This is a very important, most frequently asked question. Okay, y of t is equal to e power x of t is linear or non-linear. So first we can take y of t is equal to e power x of t as equation 1. We have to check both superposition as well as homogeneity principle. So for an input x1 of t, the output is y1 of t is equal to e power x1 of t. Let it be equation 2. For an input x2 of t, y2 of t is equal to e power x2 of t. Let it be equation 3. Then equation 2, multiply equation 2 by a. On both sides, RHS as well as LHS side, you can multiply by a. Equation 3 by b. Then add to form equation 4. So, a y1 of t plus a y2 of t. LHS I have added. Similarly, a e power x1 of t plus b e power x2 of t. This will give you equation 4. This is weighted sum of the output. We have written weighted sum of the output. Then output due to the weighted sum of input. So that output is denoted as y3 of t. Y of t will become y3 of t. So e power x of t, that x of t will be replaced as a x1 of t plus b x2 of t. So this is equation 5. So as we know, this is individual a e power x1 of t plus b e power x2 of t. But here e power a x1 of t plus e power plus b x2 of t. So we know that e power a plus b is equal to e power a into e power b. Okay, into e power b. So this equation 4 is not equal to equation 5. So the weighted sum of the output is not equal to the output due to the weighted sum of inputs. Okay. So therefore the given system is a non-linear system. I hope you understood this problem. This is a very important problem. So write carefully. Check whether the system is linear or non-linear. Here the system is y of t is equal to integral minus infinity to t x of tau d tau. See, if these expressions are given like this integral, oh, this is a very tough question, right? What is this integral and all given, we will think. But this is a very, very easy problem. Let me explain it how. So, first take the given expression as equation 1. You write simply the expression y of t equal to integral minus infinity to t x of tau d tau. Okay, for an input x1 of t, y1 of t is equal to integral minus infinity to t x1 of tau d tau. Let it be equation 2. Similarly, for x2 of t, y2 of t is equal to integral minus infinity to t x2 of tau d tau. Let it be equation 3. So multiply equation 2 by a and then equation 3 by b and then add to form equation 4. So a y1 of t plus b y2 of t is equal to a into integral minus infinity to t x1 of tau d tau plus b into integral minus infinity to t x2 of tau d tau. This will be equation 4. This is simple. So this is weighted sum of the output. So how to write output due to the weighted sum of inputs? Just replace x of tau as a x1 of tau plus b x2 of tau. This is weighted sum of inputs. So since this is an integral, we can multiply this integral inside two terms. So integral a x1 of tau d tau plus integral b x2 of tau d tau. Since a and b are constant, you can take a and b outside the integral. So a integral x1 of tau d tau plus b integral x2 of tau d tau. So here equation 4 is equal to equation 5. Same as equation. Those two equations are same. So the weighted sum of the output is equal to the output due to the weighted sum of inputs. Therefore the given system is linear. See how simple the steps are. So the answer is linear system. Check whether the given system is linear or non-linear. Y of n is equal to n square of x of n. The answer is linear. Let me explain it how. So equation y of n equal to n square x of n, y1 of n square x1 of n, y2 of n square x2 of n. So we have formed three equations. How to write equation 4? Multiply equation 2 by a, equation 3 by b, and then add to form equation 4. So the expression is a y1 of n plus b y2 of n is equal to a n square of x1 of n plus b n square of x2 of n. So how to write output due to the weighted input? Output due to the weighted input is denoted by y3 of n, which is in the place of x of n, we will write a x1 of n plus b x2 of n. So n square you can multiply inside. So a n square of x1 of n plus b n square of x2 of n. This will be equation 5. So you compare equation 4 and equation 5. See, both the equations are same. Okay. A n square of x of n is equal to a n square of x1 of n plus b n square of x2 of n. So equation 4 and 5 are equal. The weighted sum of the output is equal to the output due to the weighted inputs. Therefore, the given system is linear. Check whether the given system is linear or non-linear. Y of n is equal to x of n plus 1 by 2 x of n minus 2. This is a non-linear system. This is also a most frequently asked question. Solution. Let us write equation 1 as given in the problem. Equation 2 is written for an input x1 of n. For an input x2 of n, equation 3 is written. Multiply equation 2 by a, equation 3 by b, and then add to form equation 4. So a y1 of n plus b y2 of n is equal to a x1 of n plus a divided by, so multiplication, right? So 1 into a, you will get a divided by 2 x1 of n minus 2 plus b x2 of n plus b divided by 2 x2 of n minus 2. This will give you equation 4. This is nothing but weighted sum of outputs. Let us write output due to weighted sum of inputs. Okay. So y3 of n is equal to, so the question is x of n. So in the place of x of n, a x1 of n plus b x2 of n. Then plus 1 by 2 into x of n minus 2. So in the place of x of n minus 2, you can write 2 into a x1 of n minus 2 plus b x2 of n minus 2. So here in equation 4 we have separate terms, a divided by plus b divided by, but here both are combined, 1 divided by. You cannot separate. Okay, you cannot separate those terms. So equation 4 is not at all equal to equation 5. So the weighted sum of output is not equal to the output due to the weighted sum of inputs. The system is non-linear system. Check whether the given system is time variant. Okay, time variant or shift invariant or time variant system. Y of n equal to x of n minus 2. The answer is time variant. Let me explain it how. So y of n is equal to x of n by 2. The output due to the input delayed by k units is y of n comma k is equal to x of n by 2 minus k. Just delay the input by k units. So delay means minus k. Advance means plus k. So we have to delay the input by k units, that is n by 2 minus k. This will be equation 1. Then the output is delayed due to k unit. Okay, what is the definition of time invariance? If there is a delay in the input, there will be the delay in the output also. So there is a delay the input by k units. So what about the delay in the output? You have to replace, output is delayed means n minus k by 2. So there is a difference. X of n by 2 minus k is completely different from x of n minus k by 2. Okay, just delay the signal by k units is first expression, but the second expression you have to replace n by n minus k, whatever the place of n may be. So here it is n by 2, so n will become n minus k by 2. So equation 1 is completely not equal to equation 2. So the given system is a time variant system. I hope you understand the problems. Let us see some more problems also so that you can understand clearly. X square of n minus 2. Check whether the given system is time variant or time invariant. So first of all, output due to input delayed by k units. So just you put minus k. So n minus 2 minus k. Output delayed by k units. Okay, output delayed by k unit is, in the place of n you should write n minus k. If you write n minus k minus 2, this is the order, right? N minus k minus 2 can be written as n minus 2 minus k also. So equation 1 is equal to equation 2. So both the equations are equal. The given system is time invariant. Let me tell you another question in the same way. X of n square minus 2. What will you write? X of n square minus 2. So listen carefully. X of n square minus 2 minus k will be the first expression. Second expression will be x of n minus k the whole square minus 2. Okay, you have to replace n by n minus k. So n minus k the whole square minus k. So both the equations will be not equal. That system will be a time variant system. But here square will be outside. Right, so x square of is different by x of n square. So y of t is equal to x of minus 2t. The answer is time variant. Let us see how. So x of minus 2t, output is delayed by t seconds. Continuous time system. So you should not use k. You have to use another variable t. So you just delay the signal minus t seconds to form equation 1. X of minus 2t is given. So just delay the signal minus t. Second, output is delayed by t seconds. So you have to replace small letter t by t minus t. So what will happen? Minus t minus 2t plus, if you multiply minus 2 inside the bracket, minus 2t plus 2t. Okay, this will give you equation 2. So equation 1 not equal to equation 2. The system is time variant system. Check whether the system is time invariant. You have given a differential equation. So as I explained in the previous video regarding the definition, time invariant system, if a differential equation is given, check the coefficients of it. If they are constants, that system is a time invariant system. If one of the coefficient belong to a function of time, for example t variable is available as one of the coefficient, that system will be a time variant system. Let us check the coefficients for this problem. All the coefficients of the differential equations are constant. See, 1, here 2, here 3, here 1. Coefficients are constant. So the given system is a time invariant system. So here another expression is given. Let us see the coefficients. 1, 1. Here it is t. 1, 1. So one of the coefficient is function of time. The given system is time variant system. Check whether the given system is static or dynamic system. Y of n is equal to x square of n. So for different values of n you can substitute. So n In the place of n, you can write -2, -1, 0, 1, 2. So the answers are same. Whatever the input you are substituting, the same output, input and output values are equal. So both are equal. This system is called a static system. Y of n is equal to log 10 of modulus of x of n. Log to the base 10 modulus of x of n. The answer is static system. So substitute for different values of n. So the same, whatever you are substituting, you are getting in the output side also. So the present output depends on the present values of input alone. So therefore the given system is static. Check whether the given system is stable or unstable. Y of t equal to t plus 5 u of t. It's an unstable system. Let us check it how. Y of t is equal to t plus 5 u of t. What about u of t? U of t is equal to 1. We know the signal, right? It is equal to 1. Sorry. It is equal to 1 for t greater than or equal to 0. If it is a continuous time signal, t you have to write. For t greater than or equal to 0, you can get different values of t here, so that you can get the output. So since t tends to, if t is infinity, y of t is equal to infinity, right? So here the output grows unbounded. Therefore the system's bounded input produce unbounded output. Therefore the given system is a unstable system. Check whether the given system is stable or unstable. H of t is equal to e power minus 2t u of t. H of t is given. So you can write the condition, necessary and sufficient condition for a system to be both stable. That is integral minus infinity to infinity. Modulus of h of t dt should be less than infinity. In which h of t is given in the problem. You can substitute the problem. E power minus 2t u of t. So what is u of t? We know it is 1 for greater than or equal to 0, the value of t. So you can change the limit as 0 to infinity, modulus of e power minus 2t dt, which is equal to e power minus 2t divided by minus 2. So the limits are 0 to infinity. So e power minus infinity, e power 0. E power minus infinity is 0. E power 0 is 1. We will get 1 by 2 as answer, which is less than infinity. So the condition is satisfied. The value of the integral is less than infinity. Since the impulse response is absolutely integrable, the given system is a stable system. Next, h of n is equal to u of n. So this system is an unstable system. Let me tell you how. Write the condition. Since this is a dt system, we have to write the summation expression. Summation n is equal to minus infinity to infinity, modulus of h of n is less than infinity. So what about h of n? Is an impulse response of the system. So you substitute what is h of n given in the problem, that is u of n. So what is u of n? U of n is equal to 1 for n greater than or equal to 0. So you substitute 1 here and you can change the limit as 0 to infinity. So summation for all the values of 0 to infinity, for different values of n, it is 1. So 1 plus 1 plus 1 will give you infinity as answer. Here the condition is not satisfied. The answer should be less than infinity. Since the impulse response is not absolutely summable, therefore the given system is an unstable system. So these are the different problems. These problems can be asked in the 2-mark questions, in the part B question, okay, in the MCQs also they can ask. So go clearly through the video, okay. So these are the problems I have taken, and in the next video we will see the part C as well as part B problem. So part B problem will be one expression will be given and they will ask you to find all these systems. If it is a static system or a dynamic time variant, you check all the systems, right? So like that problems I am going to take in the next video. So thanks for watching the video. Thank you.